What would it be like to fly in an airliner that could take off and land vertically, without the need for a runway? Well, in the 1960s, the German company Dornier tried to turn this dream into reality with the Dornier Do. Initially an experimental vertical takeoff and landing (VTOL) jet-propelled cargo aircraft, primarily intended for military purposes such as tactical transport and troop support. It could carry up to 36 soldiers, and also take off and land in remote areas and improvised locations. The design of the Do depended heavily on the configuration of its 10 engines. It used 2 British-built Bristol Pegasus engines mounted on the inner nacelles, for conventional flight, and 8 Rolls-Royce RB162 lift engines, mounted vertically in groups of 4 on the outer nacelles, for vertical takeoff and landing. It reached a top speed of 730 km per hour, with a range of 1,800 km per hour. Engineers faced several challenges during the development of the propulsion system. The resonance of the engine's vibrations with the structure risked damaging the aircraft, and the risk of exhaust gas re-injection during vertical flight. These problems were solved by positioning the lift engine nozzles at 85 degrees and making them adjustable to control the flow of exhaust gases during takeoff and landing, ensuring precise and safe maneuverability during critical phases of flight. During the late 1950s and 1960s, the German Air Force became increasingly concerned that, in the event of a major conflict with the Eastern Bloc, its airfields would be highly vulnerable to attack. To counter this threat, one option was to use the national highways, so aircraft with short takeoff and vertical landing (STOVL) capabilities were needed. In 1961, Dornier was asked to begin the design of a transport aircraft with vertical takeoff and landing. The design of the flight control system was crucial for aircraft that performed vertical flights, especially for fault management. Dornier developed the Do-960 hybrid computer to calculate complex equations representing the aircraft's behavior and performance during flight. In addition, the flight control philosophy used on the Do-31 was more akin to that of a conventional aircraft than that of a helicopter. Of the 3 prototypes produced E1, 2, 3 only the latter was complete. On 28 February 1968, the first flight was made. During the flight tests, test pilot Dornier Do performed several exploratory maneuvers with the Do-31, such as a backward flight, demonstrating the aircraft's excellent flying ability. Dornier also had ambitions to sell the aircraft for civil use, so he presented it at the Paris Air Show in 1969. The aforementioned interest in the public led to negotiations with Douglas Aircraft and LTV for a later unfinished collaboration. The Do-31 set 5 new world records for vertical takeoff aircraft, including the highest climb speed to date of 514 km per hour, set by pilot Dornier Do. NASA, interested in the aircraft, had the Do-31 tested by Neil Armstrong, whose response was positive for both features and performance. The Do-31 was the first, and so far only, vertical takeoff transport aircraft ever built. The weight of the 8 lift engines compromised its flight range, and its top speed compared to other conventional transport planes. Moreover, the German government, given the lack of interest from other NATO countries, was not inclined to bear the high costs required for a large-scale development of this type of aircraft on its own. The project was thus abandoned in April 1970. The epic of the Dornier Do-31 is a story of bold innovation and daring challenges. This extraordinary aircraft, with its unique vertical takeoff capability, raised the eyes of the world to new horizons in air transport. Despite the technical and political difficulties it encountered along the way, the Do-31 remains an icon of aeronautical research and engineering of its time, a symbol of unparalleled ambition and progress.